Hello everyone, in today's video we'll be covering the whole paper of CAIE A Chemistry, October-November 14, paper 22. So the first question is about ionization energies. Successive ionization energies of elements from magnesium to barium are given in the table. Magnesium to barium, which basically is group 2, right? Explain why the first ionization energies decrease down the group. So when you're talking about ionization energies and trends, you should know that you should refer to three things. The first is distance, the second is charge, and the third is shielding effect and its overall impact on the nuclear attraction. So down the group, what happens? So despite nuclear charge increasing, there is an increase in distance between and nucleus, right? And also increase in number of shells, therefore increase shielding effect, right? So what does that do? Thus reduced nuclear attraction. Okay, so that is easy 3 marks, right? Explain for each element. Explain why for each element there is a large increase in between the second and third ionization energies. So in group 2, right, so group 2 have 2 valence electrons, like 2 electrons in its outer shells. So why is there a huge increase between the second and third ionization energies? And to word this, you can word this in many ways, but the proper way to word this would be third electron removed from an inner shell, because the entire outer shell is removed, therefore reduced shielding effect, so stronger nuclear attraction. You can also mention the decreased distance between the valence electrons and the nucleus, and also like the increased effective nuclear charge, but the main point is this: the reduced the reduced shielding effect due to an inner shell. Okay, so let's move on to the next question. It's a mass spectrometry question. A sample of strontium with atomic number 38 gave the mass spectrum shown. The percentage abundances of each are given above each peak, right? So the first question is about the full electronic configuration of strontium. So the atomic number is 38, so there has to be a total of 38. And so we just go normally, so 1s2, 2s2, 2p6, 3s2, 3p6, right? And now here's 18 electrons, and from 38 take away 18, so we have 20 left, and therefore you can fill the 3d subshell, first the 4s and then the 3d, right? So 3d 10, 4s2, right? And then 4s2, 3d 10, right? 4p6. So this is how it goes. So it goes from 3d10, 4s2 to 3d10, right? And then to 4p6, and then it goes to 5s2, right? So first you fill 4p6, and then you get 5s2. And besides, the easier way to do this would be that strontium is in like it has 5 shells, and it's in group 2, so it has to have a 5s2. Does that make sense? Yeah. So explain why there are 4 different peaks in the mass spectrum of strontium. So these are just the different isotopes of strontium that are naturally occurring. So all you have to say is that 4 naturally occurring isotopes of strontium. Right, I believe strontium is SR. So calculate the atomic mass of, or the AR of the sample of strontium. Give your answer to these 3 significant figures. So the easiest, like the way to calculate this is multiplying, like the sum of multiplication of this and this, right, divided by 100. So the R would be 0.56 times 84 plus 9.86 times 86 plus 7 into 87 plus 82.58 into 88, and this whole thing divided by 100. Your AR should be 87.710, which is approximately equal to 87.723 significant figures. Okay, so 87.7. The compound of barium A is used in fireworks as an oxidizing agent to produce a green color. Okay, so explain in terms of electron transfer what is meant by the term oxidizing agent. So an oxidizing agent is something that oxidizes another compound and therefore undergoes reduction itself. So because it undergoes reduction, meaning it gains an electron or takes an electron from another species, right? A has the following percentage composition by mass, so Ba 45.1, Cl 23.4, and O 31.5. Calculate the empirical formula of A. You want to calculate the empirical formula. This is something you've done in your GCSE years. So percentage, or which can be mass as well, Ba, Cl, and O, right? O. So 45.1, 23.4, and 31.5. And then you write its AR. For BI, it's, I believe, 137.3, 35.5, and 16. The AR values are given in your periodic table in the data booklet, so make sure to use that. And then you calculate the moles. So 45.1 divided by 137.3, that's 0.328, right? This one is 0.659, and this one is 1.97. And the ratios, so this is the smallest, so this will be 1. This is approximately twice this, so 2, and this is approximately 6 times this, so 6. Therefore, your empirical formula should be BaCl2O6. Right? Some reactions involving magnesium and its compounds are shown in the reaction scheme below. So it's something from periodicity and the group 2 lesson. So give the formulae of X, Y, and Z. So X, magnesium reacts with water to give XAQ. We assume this is cold water, so MgOH2, right? It gives magnesium hydroxide. Y is with steam, so basically hot water, and that would give magnesium oxide, MgO. And Z is HNO3, takes place, so it'll be MgNO3 too. Recall NO3 anion is NO3 minus, and Mg has oxidation state of +2, and therefore there'll be 2 of NO3 anions. Name the reagent. So name the reagent. You need to convert Y to Z in reaction 1 and write an equation for the reaction. So the reagent from Y to Z. So Y is MgO and Z is MgNO3 too. So there should be an acid-base reaction, right? Because MgO is a base. So you would use, optimally you would use nitric acid or HNO3, so nitric acid. You cannot write HNO3 because it says to name the reagent. If you write the formula, you won't get the mark. And the equation would be MgO plus HNO3 to give MgNO3 2 plus H2O. Acid-base reaction gives us salt and water, and there's 2 anions, so that. How would you convert a sample of Z solid to Y solid in reaction to Z solid? So MgNO3 to solid, MgNO3 to MgO. Oh, that's a thermal decomposition reaction. So they didn't ask for the reaction here, they're just asking for how would you convert it. So the answer would be thermal decomposition. Or in thermal decomposition, you just apply heat, so you just say apply heat. I believe either one should be acceptable. And then give equation to convert for conversions of Mg into X and Z into Y. So Mg to X was MgOH2, so Mg plus H2O gives MgOH2 plus H2, right? So there has to be two O's, so 224, 224, right? This is perfectly balanced. And Z to Y. Z is the thermal decomposition reaction. So this is something, either you can keep it by heart, or you can balance the reaction every time you write it out. But because it's time consuming, I just recommend by hearting it. So MgNO3, 2 thermal decompose gives 2 MgO plus 4 NO2 plus O2. Okay, that's an easy 21 marks in less than 10-11 minutes, right? So let's move on to the next question. The contact process for the manufacture of sulfuric acid was originally patented in the 19th century. It's still in use today. This is useless information, except for that we're going to deal with the contact process, something you're familiar with. The key step in the overall process is the reversible conversion of sulfur dioxide to trioxide in the presence of this catalyst, right? And it's an exothermic reaction, and this is an equilibrium reaction. One way in which sulfur dioxide for this reaction is produced is by heating the sulfide ore FeS2 in air. Iron 3 oxide is also produced. Write an equation for this reaction. So this isn't something that you're given in your syllabus, but it's something that you have to answer on the spot. So let's use all the information we've been given. So reacts with air to give iron 3 oxide, so Fe2O3 plus SO2. What we have to obtain, right? Sulfur dioxide. Now all you have to do is balance this out. So there's 2 Fe here, so 2, right? And 2s, 4s, so it has to be 4SO2. So 3 oxygen, 3 plus 4, no wait, 3, 8, 8 plus 11, so 11 oxygen on the right hand side. There has to be 11 oxygen on the left hand side as well, so 11 divided by 2 is 5.5, so 5.5 O2. And that is balanced. And if you want to write it in whole numbers, then you can just multiply this whole reaction with 2. You will get whole number coefficients. The sulfur trioxide produced in the contract process is reacted with 98% sulfuric acid. The resulting compound is then reacted with water to produce sulfuric acid, which is basically oleum. Explain why sulfur trioxide is not first directly mixed with water. The reason why it's not done is because the reaction would be very explosive or exothermic. Therefore, it is dangerous. Right? That's why we produce oleum first and then dilute it into sulfuric acid. Right, equations are the two steps involved in the conversion of sulfur trioxide into sulfuric acid. So first you have to form oleum, right? So H2SO4 plus SO3 gives you oleum. H2S2O7, right? And then you dilute oleum with water to get sulfuric acid in a very risk-free way relative to just directly mixing sulfur trioxide with water, 2H2SO4, right? Sulfur trioxide and sulfur dioxide both contain only S double bond O bonds, right? Draw label diagrams to show the shape of these two molecules. So label diagrams and only S double bond O bonds. So sulfur has 6 electrons, 1, 2, 3, 4, and then a lone pair here, right? So, and in this case, there is no lone pair, right? And since sulfur is the central molecule, that's the only things lone pairs you should pay attention to. The oxygen lone pairs can be like ignored in this case. And that is the shapes. I don't think that there's any additional labels to this. Like maybe you could label that this is a double bond or this is a single bond. These are lone pairs, but I doubt that's necessary because the examiners marking your papers are aware of chemistry notations. For your diagrams in one, name the shapes and suggest the bond angles. So SO2 is, well, there's 3 pairs, right? But there's a lone pair. So this lone pair will repel more than a bond pair. So a lone pair would reduce it by 100, no, reduce the bond angle by 2.5, so 120 minus, so that'll be 117.5, right? And the shape is not perfectly trigonal planar, so it'll be bent, I guess, right? You can say that the shape is bent. Whether it's planar or not is not, like, to our knowledge. SO3 is very simple. Well, it's like, I forgot the name of the compound, but it's basically trigonal planar, right? Because because of the way it's oriented, and because it's trigonal planar, the bond angle is 120 degrees. Let's move on. The conversion of sulfur dioxide into sulfur trioxide is carried out at a temperature of 400 degrees Celsius. With reference to the Le Chatelier's principle and reaction kinetics, explain one advantage and one disadvantage of using a higher temperature. So you have to refer to both reaction kinetics and Le Chatelier's principle. So in reaction kinetics, the higher temperature would lead to a faster, like a faster rate of reaction, right? Whereas in Le Chatelier's principle, since you're asking for a disadvantage, the forward reaction is exothermic, and therefore a higher temperature would reduce the yield of sulfur trioxide. So you basically have to state like the reason and explain. So let's get to it. So firstly, the advantage. So with T equal 400 degrees Celsius, greater rate of reaction, and the reason for that is because increased kinetic energy of particles, but therefore greater proportion of particles. Wait, let me just zoom in because I'll have to write a lot here. Right, greater proportion of particles with kinetic energies greater than or equal to the activation energy. And what else? Greater frequency of successful collisions. I don't remember the spelling of collisions, apologies. Anyway, so that is the advantage explained. And now regarding the disadvantage, at T is equal to 400 degrees Celsius, forward reaction exothermic, right? So you must write that it is favored by lower temperatures, right? And this part isn't necessary here. You just write this here at T equal 400 degrees Celsius. Equilibrium shifts to left hand side, therefore reduced yield of sulfur trioxide. That is the advantage and explained, right? So state the expression for the equilibrium constant Kp for the formation of sulfur trioxide from sulfur dioxide. So first you write the equation here, right, to help yourself. 2SO3, right? So the Kp would be the partial pressure square of SO3, whole thing divided by the partial pressure square of SO2 times the partial pressure of O2. Because it has no coefficient, it's just to the power 1. Now, this is a problem involving Kp. So 2 moles of sulfur dioxide and 2 moles of oxygen are put into a flask and left to reach at equilibrium. At equilibrium, the pressure in the flask goes, this is the pressure, and the mixture contained 1.8 moles of sulfur trioxide. Calculate the Kp, include the units. And it's for a whopping 5 marks. So the way to do this would be by the nice method. Alright, and this is in moles, SO2, O2 and SO3, right? So let's use all the information that we've been given. Initially, there's 2 moles of sulfur dioxide and 2 moles of oxygen. No initial moles of sulfur trioxide were given, so we're assuming it's 0. And at equilibrium, there's 1.8 moles of sulfur trioxide, and the reaction is producing sulfur trioxide. So the change in sulfur trioxide would be 1.8, right? And this is 2 mole ratio, this is 1 mole ratio, and this is 2, and therefore this would also be 1.8, and this would be 1.8 divided by 2, that is 0.9, right? And the change in this case would, because they're being used to produce the sulfur trioxide, did reduce. So 2 minus 1.8, that's 0.2, and 2 minus 0.9, that's 1.1, right? Now the total moles at equilibrium is 0.2 plus 1.1 plus 1.8, that's 3.1 moles, right? Total moles, and that is used to calculate the molar fraction. So of sulfur dioxide, I'll just write it in decimals, fractions, to ensure the most accurate final answer, right? So that'll be 2 divided by 31 in oxygen's case it'll be 11 but divided by 31, and in sulfur trioxide's case it'll be 18 divided by 31. So now we calculate the partial pressure and therefore the Kp. So the Kp would be the partial pressure of sulfur trioxide square, right? So 18 divided by 31 times 2 into 10 to the power 5 squared, whole thing divided by the partial pressure of sulfur dioxide squared, so that'll be 2 divided by 31 into 2 into 10 to the power 5 squared times the partial pressure of oxygen. So 11 divided by 31 into 2 into 10 to the power 5. The final answer you get should be 1.13 into 10 to the power minus 3, right? So 1.13 into 10 to the power minus 3, and you must also calculate the units. So this will be pressure squared, right, on the numerator side, divided by pressure squared into pressure 1, so that's pressure cubed. So that'll be pressure minus 1, right? So it'll be pascals minus 1. The reason why it's pascals minus 1 is because you're using pascals to calculate. The pascal is the unit that you're using for pressure. Anyway, let's move on to the next question. That was an easy 19 marks yet again. So the next question is about organics. So P, Q, and R are structural isomers with the molecular formula C4H8. Okay. All three molecules very decolorized bromine and the dark, so they're alkenes. P and Q do not exhibit stereoisomerism, but R exists as a pair of geometrical cis-trans isomers. That gives a lot of information. All three compounds readily react with hot concentrated acidified potassium manganate, which is an oxidative cleavage, to produce a variety of products as shown in the table. So these are the products shown when they react with hot concentrated acidified KMNO4. So S reacts with 2,4-DNPH to form an orange crystalline product, but does not react with Felling's reagent. So that means it's an aldehyde. Sorry, not aldehyde, it's a ketone. Right? But that would have been obvious once you took a look at the table. So give the structural formula of PQ, R, and S. So P is the alkene that produces carbon dioxide upon reaction with KMNO4, and that, right? So to produce CO2, you would have to have no two hydrogens attached to the carbon and the carbon double bond, and it produces the ketone, right? So if it produces a ketone, the ketone's carbon should be attached to two carbon atoms, so that'll be CH3, 2. Yeah. For Q, it's the same case again. Carbon dioxide has been produced, so H2C and CH3, CH2, CO2H, right? To produce an acid, you have to have it attached to only one carbon atom, so it'll have CH, right? And two more carbon atoms, CH2, CH3. For R, it'll give CH3, CO2H only. So on both sides there should be a CH3C double bond, right? So CH3, CH double bond, CH, CH3, and this is probably what exhibits stereoisomerism, because it can take the cis-trans form, right? There's the rotation about double bond. And lastly, S. So when oxidative cleavage happens here, in this case, when oxidative cleavage happens there, it would form CH3, CH3, right? And there would be a double bond O. But it's in structural formula, so I'll just have to write that in structural formula. Apologies. CH3CO, CH3. That is a propanone, right? Yeah, that's a propanone. So this question, explain what is meant by the term stereoisomerism. So compounds, it's just a definition question. Compounds with same molecular formula and structural formula, but atoms have different spatial arrangements. Simple. Let's move on. Draw the displayed formulae of the geometrical isomers of R and name them both. So R, right? So C, that's that was, if I recall correctly, butene, right? So butene. So first I'll draw the cis because preference. So C, H, 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 right? Same here, H, H, and H. So cis, you have to write this because you have to write like which form it is of the geometric isomer. So cis but 2-ene, and the other one I'll draw trans. C, H on the opposite sides, C, and this also on the opposite sides. Right, pardon the bad drawings. And this will be trans because they're on the opposite sides. But 2-ene, right? State the reagent that could be used for the reduction of S and name the organic product of this reduction. So state the reagent, so you can either write the name or the compound. Reduction of S, so that was propanone, right? So because it's a carbonyl, you can use either LiLH4 or NaBH4. In my case, I'll use LiLH4. Either one is correct, LiAlH4, and the product would be, so yeah, so it'd be propan 2 all. Next question, a series of reactions based on propanoic acid is shown. So this is propanoic acid, the compound that we're concerned with. Write an equation for reaction 1 using H to represent the reducing agent. So we know that reaction 1 is reducing a reduction reaction. So propanoic acid is reduced to propan 1 all. So CH3, CH2, CO2H plus brackets H gives CH3, CH2, CH2OH plus H2O because there's another oxygen, right? And you see that in here on the left hand side there's 1, 2, 3, 4, 5, 6, 6 hydrogens, whereas on the right hand side there's 3, 5, 7, 8, 9, 10 hydrogens. So to make this balanced, you have to add a 4 here. So what type of reaction is reaction 2? So since reaction 1 is an reduction, reaction 2 must be an oxidation. Or if you're being more technical, the conversion of an alcohol to a carboxylic acid is an oxidation reaction, right? So it's an oxidation reaction. So there's suitable reagent and conditions for reaction 2. Now in your syllabus there's 2 ways to convert like this, to convert an alcohol to the acid. The more common one is using the dichromate ion, right? So hot concentrated acidified K2Cr2O7, right? Heat under reflux. That is the reagent and conditions. Write an equation for the reaction of propanoic acid with calcium carbonate. So calcium is 2 plus and propanoic acid, so the anion CH3CH2CO2 has a single negative charge, and so there should be 2 of these, right? So propanoic acid with calcium carbonate CaCO3 plus CH3CH2CO2H gives, so 2 of these would be there because 2 of them are present with the calcium 2 plus, and from there on it's an acid-base reaction. So because there's a carbonate, produces salt, carbon dioxide, and water. So CaCH3CH2CO2 plus CO2 plus H2O. Okay. So there's a suitable reagent and conditions for reaction 3. So let's take a look at what reaction 3 is. It's the conversion of propan 1 all to propyl ethanoate. So it's an esterification reaction. So the reagent, we already have propanol, right? So that'll be the propyl part, and now we need the we need the acid, and the acid is ethanoic acid, right? Ethanoic acid, and or you can just write the formula CH3CO2H, and the conditions for the reaction would be heat under reflux with concentrated sulfuric acid. So the conditions and reactions are things that you just must have like by heart. There's no other way around it. Identify the other product of reaction 3. So it's an esterification reaction, which is also a condensation reaction. So the other product formed would be water. Well, that is it for the paper. So we were able to solve this whole paper within 30 minutes, and that was, I believe, an easy 60 marks. If you do have any doubts or didn't understand anything, do please leave them in the comment section below, and please subscribe and share with your friends.